you?
No, I made the title in a way that it's like hard to find. So.
If you search the exact title of the video to get it.
Yeah. Okay. You guys work on this first bit. Avery, what'd you get? A half mile. Okay, that's right. Just thinking about it. Walk me through your thought process.
It takes an hour. 60 minutes and 60 miles in an hour.
So, how many miles do you go in a minute? 1 mile a minute, right? If you're going 60 miles an hour, Chike, if you're going 60 miles an hour, how many miles do you go in a minute? It's just one, right? 60 miles in 1 hour? Okay, so then he logically deduced that if you're going 1 mile in 1 minute, how many do you go in 30 seconds?
Half a mile.
Half a mile. All right?
You have to like account for like turns in the road and stuff.
Okay, what about
Slow you down.
28 seconds though? What about 28 seconds? You know it's going to be less than half an hour. I want exact numbers here.
Alright.
Alright, let me walk you through this first part. $60 miles, 1 hour. Okay? I'm asking for how far you're going in seconds. So we need this to be seconds right here. Alright? 1 hour is 60 minutes. And 1 minute is 60 seconds. Okay. How many seconds in 1 hour? How do we figure this out?
What?
Well, if it's being measured by miles per hour, then couldn't you just say?
There's a lot of things you could do.
Mile for 30 seconds?
Yeah, there's a lot of things we can do, but I want to break this down so that when the problem becomes more complicated, Jamara, then you can apply that logic to those other types of problems. Okay? So, this is what we're gonna do. If there's 60 seconds in 1 minute, all right, how many seconds are there in 60 minutes? This right here, we're gonna be working on this today. All right, this is called a proportion. So I'll just write this up here. Today we're gonna be. This is what we'll be starting this week on, and then when we build into geometry, this stuff will be important to understand. Okay, how do I solve for x here? Do you guys remember this from last year?
Yeah.
What do you do here? What's this? No?
An X.
You can cross multiply. I'm going to show you a shortcut way, all right? You can cross multiply this times this is equal to this times this, all right? For example, if you had this, okay, so if we put in these guys here, this 6 times 6 is equal to 12 times 3. So you could rearrange it that way and make this 60 times 60 is equal to x times 1. All right, and then you would get 3600 equals x. And Isaac just knew in his head, oh, just multiply 60 and 60. All right? Yeah. That's what you do here. Okay, I'm going to give you a shortcut. Are you guys ready for this?
Oh, can't you just multiply the 6's and then take down the zeros?
Say that again.
No, can't you just multiply the two 6's and then bring down the zeros. Like right.
What do you mean bring down the zeros?
No, okay. So 6 times 6 equals 36, and then you add the 2 zeros.
For multiplication? Yeah, you can. For this stuff, you can use calculators, by the way. Alright? This week, we're going to be doing stuff that you can use calculators for. Alright, let me show you a shortcut that's going to come in handy for the rest of your life.
Ooh.
Okay? Are you ready? It's called the figure 8 shortcut. Isaac, are you ready? Tamara? Okay, you start opposite from the x. Alright, start opposite from the unknown. And then you go this times this divided by this equals that.
That's like spider symbol.
Did you guys follow that?
On the black list.
Did anyone follow? Okay, let's call it the hourglass then. Okay? This times this divided by this equals that. Alright?
Pretty cool.
Now we can now that we have x equals 3,600 seconds, we can, here, I'll make it right here, 60 miles in 3,600 seconds is equal to how many miles in, what did I say? 30 seconds, right? And we already know what this is going to be because Avery figured it out in his head. But with the calculator, okay, who's got a calculator?
I do. I'm still a little
Can you grab it? We need to confirm Avery's math. Okay, do you remember the hourglass? Eli B?
Oh, sorry.
What am I going to do?
So you'll do 30 times 60, and then 3,600 times.
So go ahead and do it. 30 times 60
Right.
divided by 3,600 should give you x.
Divided by 600.
Every time for anything. What'd you get?
0.5.
What do you got? 0.5. Okay, Avery? The man who knows infinity? Right, we confirmed it. Now you can do 28 seconds, right? What would you have to do for 28 seconds?
You'd have to replace that 30 with 28.
Exactly. You'd have to replace this 30 with 28. Okay, so go ahead and do that. And let's see what it is in 28 seconds. What's your estimate? Hey, let's try to estimate, okay? 30 seconds it's 0.5 of a mile. What do you guys, what would you guys, 0.4? What else? 0.43?
Dude.
0.3, 0.4, just 0.4? Iris, what do you think? JJ, what do you think?
Ooh, I don't know.
Megan, what do you think?
Yeah, 0.4 something.
0.4 something? 0.4, higher than 0.45 or lower than 0.45?
Higher. 0.4.
Okay, Megan says higher than 0.45. So whoever gets closest gets a free A for the semester, for the trimester.
I'm calling 0.45.
0.46.
No, I'm just kidding. You guys are all with us.
0.46.
0.47.
Okay, wait.
Did you do it?
Wait, what? Yeah, it's 0.4666666667.
Ah, okay.
Yeah, we could get
Well, she got it first.
No, she said higher. We got it exactly.
Oh yeah, but Chris already did it.
All right, you got an A. Hey, you got an A for the trimester.
Lies.
Just kidding. Just kidding. Okay, let's get into this stuff a little deeper now. Good warm up. I liked it. It's nice you guys did well. Okay, always try to think about a real life example of numbers put together. Okay, rate. Is a ratio between two quantities. What does this mean? What does ratio mean? You guys ever heard that word before?
To something else. Something to something else.
How do you express that mathematically? Say that again?
4 to 2 or
4 to 2?
take the chance.
Sure. Yeah. I would also say a fraction. Okay? A ratio. Fraction.
Ratio's got me really confused.
Alright, let's look at a couple examples. I'll give one, then you guys can give me some, okay? Heart rate. Okay, heart rate is an example of a type of rate. And we can express it in what's called BPMs. Beats per minute. Mathematically, as a fraction, it would be like this. Beats per minute. Okay? What does this word right here mean? Crispiet.
Beats per minute?
This word right here.
Per.
Per. What does per mean?
Every.
Because you guys are going to see it again in percent. Okay, percent. And I don't expect you to know this, but I think that you can use your understanding of the English language to figure out what this means. For each is what I like to use the most. Alright? Okay? For each. Beats for each minute. Okay? Alright, give me a couple other examples. I've got some in here, but I want you guys to think of some. Heart rate's one. What else can you think of? We just did one in the warm-up. What was that? How would you call it? What would you call it?
MPH. Miles per hour.
Right. Okay, speed.
MPH.
MPH. Alright. Miles per hour. That's another type of rate. Alright, what about this one? Performance. What am I talking about when I say performance? Am I talking about musical theater? What would I be talking about? Performance and rate. No. Basketball. Okay? Think of basketball. What does this stand for? That's another rate.
Points per game.
Points per game. Okay? Points per game. That's all I've got in my book. Alright, I want you guys to think of a couple. What can you guys think of? And you can make these up. You can make up your own rates. Okay? Chairs per pod.
What?
Chairs per pod. How many chairs there are for each pod, right? Per means for each, right? Okay? Boys per girls. Alright? How many boys for each girl in this class? I don't know if that one works. Okay, classrooms per school. Desks per classroom. Alright?
Would be on the quiz, make up your own one.
You know what? That's a great suggestion.
Make up your one and give an example. That
Maybe,
makes sense.
yeah, I like that idea. We could do something like that. Okay, let's do a problem. If there are 10 desks per classroom.
Did you write that?
Yeah, you do have to rate this. And 10 classrooms per school. many desks in the school? I'm sure a lot of you guys already know the answer.
100.
Set up an equation, alright? I want you to set up an equation. Does anyone know the answer already?
Yeah, 100.
100,
What?
right? If there's 10 desks in one classroom and there's 10 classrooms, each of them has 10, 10, 10, 10, 10, 10. There's how many, Iris? 100. Okay, but I'm going to show you something cool, alright? I'm going to show you something that I think is really awesome. And then later on, when you take other science classes, specifically chemistry, this stuff is going to come in handy because we're going to be doing math with words, okay? You'll see that math has a set of rules that you can apply to more than just numbers. Okay, how do I set this up? 10 desks per classroom, how do I set that up as a fraction? Jamara. 10 desks per classroom. What does the per tell you to do?
The per is for each.
Yeah, and like, how do I, what's the symbol for that?
Oh, you put 10 desks or
What do I do now? 4?
no, over.
Oh, over? Like this?
Yes.
Okay, that's right. And then what do I put on the denominator?
10 classrooms.
10 desks per classroom. How many classrooms?
10. Oh, school.
No, just this part right here. Just this part right here. 10 desks per classroom. How many is that? Is that 3 classrooms?
10 classrooms.
Does it say 10 classrooms right here?
No.
It's 1,
How
right?
many?
Classrooms.
10 desks per 1 classroom. Are you okay with that? Why that is?
Can you just write
Sure.
classroom?
10 desks per classroom. I'll show you why it's good to write this one, right? What we're about to
Instead
do.
of 10 classrooms.
Oh, we're doing the old.
Yeah, we're gonna be crossing stuff out. Okay? You've already learned canceling. Okay? Times. Now, how do I express this, Bennett? 10 classrooms per school. Okay? 10 classrooms per school.
10 classrooms per school.
Yeah, so 10 classrooms
How many schools?
per school. How many schools are there?
One.
1 school. So how do I write that right here?
10 over 1 school.
10 classrooms per 1 school. Okay. That's great. Now we just have a couple fractions. How do you multiply fractions?
You like reciprocate and then
How do you multiply fractions?
you flip it. You flip the other one on the.
That's how you multiply fractions?
That's how you do it. Yes, and then you
That's how you
reciprocate.
divide.
That's only for
You
division.
reciprocate, and then you
That's
multiply.
division, my friend. That's how you divide
Yeah.
fractions.
Multiply across.
You
Multiply
straight
across.
across.
Okay, what's 10 times 10?
10 times 10 is 100.
100.
Over 1.
What's desks times classrooms? Because you can't just get rid of stuff here. Alright, remember, we've got desks and we've got classrooms.
Yeah.
Desk classroom.
What's desk classrooms? Desks, classrooms. We'll just put desks times classrooms. Okay?
Desks in class.
What's 1 classroom times 1 school?
Classroom school.
1 classroom school. 1 classroom times 1 school. Alright, now look at this. Remember, what can you cancel?
Classroom.
Okay, whatever's in the numerator that's also in the denominator, you can cancel it. Right? Eli? So, I can cancel this and I can cancel that. What are you left with?
100 desks in 1 school.
100 desks. What does this mean?
Per.
Yes, 100 desks per what? 1?
One school.
Voila. Okay? Does that make sense?
Yes.
Okay, do you see how math is just a set of rules that you can apply to anything? Alright? Instead of desks and classrooms, this is just as if I said 10D, times 10c, all right? 1c, 1s. Go ahead. All right, same thing's gonna happen. You're gonna get, because it's multiplication, you're gonna get 100 d times c, and then 1c times s, and then you can cross these off, and it's essentially the same thing. All right? Yeah, JJ?
Oh, I was just yawning.
Did you enjoy that?
Yeah, it's very fun.
Okay. Cool. You want to try another one?
Sure. I wasn't yawning in a bad way.
No,
I was
that's fine. I
so
just want to know.
tired.
Do you guys want to try another one?